Hello everyone. With two signals coming from your microcontroller and this little circuit here, we can drive this DC motor in both directions. This circuit converts a low voltage, low current signal into a high voltage, high current signal. The left part of the circuit is a voltage level shifter, and the right part is a current amplifier. The left part is centered about this op-amp, which does the actual converting. But how? Well, the op-amp has a positive and a negative power supply. It also has a positive and a negative input pin. And finally, it has an output pin. If at any time the voltage we see at the positive input terminal is greater than the voltage we see at the negative input terminal, then the output voltage will become the positive input voltage. The other way around, if the positive input pin sees a voltage lower than the negative input pin, then the output voltage will become the negative input voltage. This IC here in the middle contains two op-amps, as you can see in this diagram. One at the left, one at the right, and it also has a positive and a negative power supply, and it's shared by both op-amps. At the output of the op-amp I have connected an LED to see what it does. In this configuration I have a higher voltage at the positive input terminal and a lower voltage at the negative input terminal. And as you can see, the output is high. Now if I change that around, then you will see the LED remains off, as is the output voltage, because now the voltage at the positive input is lower than the one at the negative input. And how do we use that in this circuit? Well, if we take the power supply from the microcontroller, the 3.3 volts here, and we add two resistors of equal size, this and this one, in series, then we have what we call a resistor divider. And the voltage in the middle will be half of it, 1.65 volts. Now, if the microcontroller outputs a high voltage, the digital one, its voltage will be 3.3 volts, and that will always be higher than the 1.65 volts. Therefore, the op-amp outputs its positive input supply voltage. And the other way around, if the microcontroller outputs 0 volts, that will always be lower than the 1.65 volts. So, the op-amp outputs the negative power supply, 0 volts, or ground. And doing that, we now have converted our voltage level from 3.3 volt to whatever we feed this op-amp. All that remains now is the current amplification. The current amplifier. If the output of the op-amp is VCC, then the base of the transistor will conduct, and will not stop doing so until the emitter voltage here is just as high as the VCC here. If the output from the op-amp is 0 volts or ground, then this base of this transistor will conduct and will not stop doing so until the voltage of its emitter here is just as low as the ground here. In both cases, it adds a lot of current capability. Now, how do we make the motor turn? Well, we have to supply voltage to it, and the ground, of course. We do that here. We select our ESP and make a digital write to pin 2, and we make it 0. And the circuit will then convert that into ground. The second pin we will turn high, which the circuit will make VCC. Now we have a voltage applied over the motor, and it will turn around. Then later, we turn the voltage off again, and the motor will stop turning. Then we will make the first pin high, which will become VCC, and the other pin 0, which will become ground. that will make the motor turn the other way around. And that's basically it. Thank you for watching.